All right, the last thing we're going to talk about in section 10.8 is powers of I. If I have i's to a certain power and I want to be able to simplify them. We already know that I squared is equal to -1, right? But what is I cubed equal to? And what is I to the 4th equal to? And I to the 8th and I to the 475th power? I don't know. Let's see if we can simplify them in a manner that kind of shows us a pattern and maybe an easier way to simplify them if our number, our exponent, is really high. Well, think about I cubed really being 3 i's, or I could say an I squared times another I, right? I squared times I is the same thing as I cubed. Well, if we know that I squared is the same thing as -1, then I squared times I is really the same thing as -1 times I, or -I. So really, I cubed is the same thing as -I. Okay, what about I to the 4th then? Well, if we use that same idea, that I to the 4th is the same thing as I squared times another I squared, right? There's 4 of them. And if we know that I squared is equal to -1, well then, I squared times I squared is the same thing as -1 times -1, which is just +1. So I to the 4th is equal to +1. Okay, what about I to the 5th? Well, I know that I to the 5th is 5 i's, or can I say I squared times one more I? Well, I squared times I squared, that's 2 negatives, making a +1, times I is just +I. Do the same thing with I to the 6th, and I to the 7th, and I to the 8th, and see if you can come up with a pattern. I to the 6th is really I squared times I squared, or 3 I squareds. Well, if I squared is -1, then really I have -1 times -1 times -1, or -3 cubed, right? 3 of them. Well, an odd amount of negative numbers is going to give me a -I. Or I to the 7th is I squared times I squared times I squared, that's 6 of them, but 1 more I to make 7. I squared times I squared times I squared is going to be a -1, and that -1 times I is going to give me a -I. I to the 8th power is I squared times I squared times I squared times I squared. That's 4 I squareds. Maybe you can think of it as this, I squared to the 4th power, right? That's the same thing as I to the 8th. And if we know that I squared is -1, well, what's -1 to the 4th power? Well, what's 4 -1s multiplied together? Well, an even amount of -1s is going to give me a +1. So what happens if I give you a really large exponent? Instead of starting at I squared and finding all of them all the way down, maybe you can notice a pattern, and maybe we can find a way to more easily simplify our powers of I. Let me show you a few examples where the exponent is pretty large. Look at example number 5a, I to the 19th power. Instead of doing that process 19 times, let's see if we can find an easier way to simplify these powers. We know for sure that I squared is -1. So let's start with that. And then we can think about how many I squareds will it take to get me as close as possible to I to the 19th. Well, what's 19 divided by 2? Well, I could say 9, right? Well, 9 times 2 is 18, but I really need 19. So I need 1 more I. So can I really say that I have I squared, 9 of them, and then 1 more I for a total of 19? And then if we know that I squared is the same thing as -1, well then can I really say that I have -1 to 9th power times I? So now we can figure out what -1 times -1 times -1 9 times is. Well, if I have -1 and I'm multiplying it an odd number of times, 9 times, then I know my answer is going to be -1. So then I really have -1 times I, or I can say just -I. So I to the 19th is the same thing as -I. Let's do another one. I to the 64th power. Well, if I know I squared is -1, let's figure out how many I squareds we need. Well, what's 64 divided by 2? 32, right? And so I squared to the 32nd power is really I to the 64th. So I have an equivalent version of my original problem, right? And if I know that I squared is -1, then I really have -1 to the 32nd power. Well, if I have -1 and I multiply it 32 times, an even number of times, isn't an even number of negatives going to be positive? So I know that -1 to the 32nd power is really going to be +1. So I to the 64th is really just equal to 1. All right, last one. I to the 49th power. Let's start with I squareds. how many times does 2 go into 49, or how many I squareds can we get as close as we can to 49? I said 24, which is 48, but I need 49, so I need one more I. Well, if I squared is -1, then I really have -1 to the 24th power times I. And -1 to an even exponent is going to be a +1, and +1 times I is just going to be I. All right, now that we've talked about multiplying, dividing, rationalizing, and simplifying powers of I, why don't you pause the video and try these 3 problems, and then come back and see if you got the same thing I did. So for the first one, if I want to rationalize, remember we want to multiply the top and the bottom by the conjugate. After foiling through and distributing through the 7, I distributed the 7 to the top and I got 21 plus 14i. When I foiled the bottom, I got 9 plus 6i minus 6i minus 4i squared. The 2 middle terms canceled, and I also noticed that I have an I squared. I know that I squared is the same thing as -1, so I really have on the denominator 9 plus 4, or I can say 13. So I have 21 plus 14i all over 13. Not all 3 terms have a common factor, so I can't reduce it. That's my final answer. Did you get the same thing? All right, let's simplify I to the 12th now. I to the 12th. Well, I'm going to change it into I squareds. I know that it takes 6 I squareds to get me I to the 12th. And I know that I squared is the same thing as -1. So -1 to the 6th power, if I'm taking a negative number and raising it to an even exponent, I know I'm going to be a +1. So what about I to the 35th? Well, how many I squareds does it take to get me to 35? Well, I can say 17. That's going to get me to 34, and then I would just need one more I. Then I can say that I squared is the same thing as -1. So now I have -1 to the 17th power times I. -1 to an odd exponent is going to give me a -1, and -1 times I is -I. Ooh, hopefully you got the same answers that I do, so you know you're on the right track. Make sure you practice more by doing your homework, and let me